I've got a question for you. If someone asked you to demonstrate a password attack, would you be able to do it? Well, the objective I have for you and I in this nugget is that as a result of watching this nugget together, I'd like the answer to be a resounding yes. Here is the setup that we can follow. On our Windows server, we are going to, this is not good for production, but in our lab, we are going to enable Telnet, specifically the Telnet server. And you might be saying, hey Keith, that's a big vulnerability. And yes, it is. Now, once Telnet is enabled on that server, the second thing I propose we do is go to our Windows 10 machine and we'll download and install Kane Enable, which is a huge tool set of goodies. And the one technique I'd like to share with you is how we can use it to do what's called an ARP poisoning attack. It also uses sniffing to identify the various hosts on the network. And then so that we have something to eavesdrop on, let's go ahead and use this guy right here, our Kali Linux box, as a Telnet client. And what we'll do is when the Kali box attempts to connect over to the Windows 2012 server with Telnet, and the server responds, we can have our Windows 10 machine running Kane Enable act as a man in the middle. So that in reality, the traffic the Kali box is sending to the server is actually going to our Windows 10 machine, and then the Windows 10 machine can go ahead and route it over to the Windows 2012 server. And when the 2012 server responds, it's going to actually be sending the packets, well, more specifically the frames, over to Windows 10, and then Windows 10, after it has a nice look at that, can reroute it back to the Kali box. And the basics of how an ARP poison routing attack works, and in Kane Enable, that's the terminology they use, APR, is that we do MAC address spoofing. If the Windows 10 machine has the MAC address of AA, and MAC addresses are actually 12 hexadecimal characters making up 48 bits, but for this example, let's say the Windows 10 layer 2 address is AA, and that the Windows 2012 server is BB, and our Kali Linux box is CC. And what we can do is we can do ARP poisoning of the ARP caches on the Windows 2012 server and the Kali Linux box. We can make the Kali Linux box think that to reach the .212 address, it should forward it to the layer 2 address of AA, which is our attacker. And we can trick the Windows 2012 server into thinking that to reach .109, the IP address .109, that it should forward also to the layer 2 address of AA. And that's what causes all the traffic between the Windows 2012 server and the Kali Linux box to be routed through the attack machine, all through doing ARP poisoning of the ARP caches on our Kali Linux box and our 2012 server. So we'll log on as administrator. It's going to bring up Server Manager by default, and let's go under Manage in the upper right hand corner here. And from the drop down, we're going to select Add Roles and Features, and we'll add the Telnet server function. So we'll click Next a few times until we get to the Features section, which is right here, and then we'll scroll down to Telnet. So scrolling down, here we have Telnet. We have a Telnet server. And while we're here, let's also go ahead and make this a Telnet client in case we need to launch Telnet from the server. And heck, while we're here, let's also make this a TFTP client in the event we ever need to TFTP anywhere as well. And with those three selected, we'll click on Next. Then we'll click on Install. And I'll let that go ahead and finish. And even without the magic of editing, that shouldn't take too long. All right, it says it's done. We'll click on Close. Next, we'll go up to Tools in the upper right-hand corner. And after clicking on Tools from the drop-down, let's go down to Services and make sure that the Telnet server service is running. These are sorted currently in the alphabetical manner here. So we'll scroll down until we get to the T's. And there's Telnet, and it is disabled as far as startup type. So we'll right-click on it, go to Properties from the drop-down menu, and then specify that we want it to be automatic. So it'll automatically start up, and click on Apply. And we also want to go ahead and start it right now. So we'll click on the Start button and click on OK. I just want to verify that it is currently running, which it is. That's great. So now that that's running, let's go ahead and verify that the basic functionality of Telnet works. We'll hop over to our Kali Linux box. So logged on as root, we'll open up a shell. Let's go ahead and type in Telnet. And we want to go to 192.168.1.212, which is the IP address of our server, and press Enter. And let's log on as administrator with our administrator password. And sure enough, we're telnetted in. So now that we have basic functionality, let's go ahead and we'll close that Telnet session, or at least I closed that window. And let's go over to our Windows 10 machine. And let's bring up Chrome. And in Chrome, let's do a search for Kane and Able, just like that. And this is the website we're looking for, www.oxid.it. So let's go ahead and we'll click on that. And here's a download link for Cane Enable version 4.9.56. So we'll go ahead and select that. And I've got my browser saying that this is a not safe site to be at. So I'm gonna, oops, let me go ahead and let me just grab that URL. I'm just gonna copy the URL for a moment, put it in my clipboard by right clicking, going to copy, and I'm gonna close that browser. I'm gonna click on the Windows icon in the bottom left-hand corner, type in Internet, and in Windows 10, they still have Internet Explorer still available. So we'll launch Internet Explorer, and we'll paste in that same URL, www.oxid.it. We'll click on Projects, and what I want to do is scroll down just a little bit to Cane Enable, which is right here. And then we'll go ahead and download the version 4.9.56. So it says, do I want to run it or save it? I want to save it. So we'll click on the Save button, and then it's going to download it to my computer. Also, it's a good thing this is a VM and not a production system, because anytime that we're downloading attack or hacking tools, there is a large possibility that there is some extra quote-unquote stuff that's also being injected into our machines. So I'll click on the button that says View Downloads. It's complaining that the publisher of the program couldn't be verified, and I'm going to go ahead and click on Run anyway. And then click on Yes for user account control, and that'll proceed to do the install of Cane Enable. So from here, we'll just click on Next a few times and Next. It says the installation is complete. We'll click on Finish. It's also saying that the program comes with WinPCAP 4.13. Do you want to install the packet driver now? Now, because, let me just verify something. I think we already have Wireshark installed on this Windows 10 computer, and as a result, WinPCAP already got installed. So I guess we could err on the side of caution. I'm going to click on Install. And it says this version of Windows is not supported by WinPCAP 4.13. The installation will be aborted. I think we already had WinPCAP, so that's not a big deal. So let's go ahead and close the Downloads view from Internet Explorer. I'll close the browser. And now we have the icon for Cane Enable right here. So we'll go ahead and we'll double click on it to launch it. We'll say yes to user account control. Now, although there's lots of functionality right here in Cane Enable, there's two basic things that we want to do. Number one, we want to go ahead and click on this icon up here. We want to sniff the network. So we're going to click on this little icon for the network card to start the sniffer, and it's also asking me which interface do I want to use. I only have one interface in this Windows 10 machine, so with that selected, I'll click on OK. I'm going to leave all the other defaults in place. I'm also going to click on the sniffer tab right here. And it looked like that sniffer didn't start. So I'm going to go back up to this icon and click on the Start Sniffer one more time. And I've got a message giving me a warning about offloading regarding the network card. I'm going to go ahead and click on OK and hope for the best. And with that sniffer tab selected, down here at the bottom, I'm going to go to APR, which is ARP Poison Routing. And this is where we can add the host that we want to do the poisoning for. If we go back to the Host tab here on the bottom, anytime it learns about a device on the network, for example, let's say a device does an ARP request and there's a reply, it can populate that information regarding devices that exist on the network. So there's our Windows 2012 server, and there's our Linux box at .109. So now that it knows about those, the longer we leave it sniffing, the longer it could learn. But now that it knows about those two, let's go down to APR. So I'm going to click my mouse right here, and when I do, this plus symbol now becomes active. So what I'm going to do is on the left-hand side, I'm going to specify .109. And then on the right-hand side, I'm going to specify .212. Now it's a little bit difficult to see, but because this was highlighted earlier, it's shaded over here on the left-hand side. So basically what this means is that the .109, our Kali Linux box, and .212, our Windows 2012 server, are the two devices which we are going to do an ARP poisoning attack against. So with those two selected, all we need to do is click on OK. So I'll go ahead and click on OK. And it currently says idle, and to actually launch the attack, we need to go ahead and click on this little icon. So let's go ahead and click on that icon, and that will launch the attack. So now it changes status to poisoning, and based on the platform you're at and the version you have, we also may have some confirmation down here regarding packets that are being routed back and forth between those two hosts. So now with this poisoning attack that's happening, let's go back to our Kali Linux box, and let's open up a telnet session over to the Windows 2012 server. So from here, we'll type in telnet space, and we'll go to the IP address of our Windows 2012 server, which is 192.168.1.212, and press enter. All right, so that looks promising. Let's log on as administrator. Now, as I typed each of those characters, not only did those characters go over to the server, but they also got sent back to me from the server and echoed on my screen. So I'll press enter, and then when we do the password is not echoed right back here to my screen. It's simply given to the server. So my password is nugget, !23 with a capital N at the beginning, and we'll press enter. And we are in. Now, if our eavesdropping and man-in-the-middle attack was successful, we should be able to go back over to our Windows 10 machine running Cain enable. And it should not only have eavesdropped on that conversation, but it should also be able to show us what the passwords are. And let's go ahead and click on this icon once again to stop the attack. And down to the bottom left, we have this option for passwords. If we click on passwords, you'll notice that under Telnet, we have a count of 1. So with this Telnet selected, we can go ahead and select this session that it recorded. And if we right-click on that session, and then from the drop-down, click on View, here we can see the logon as administrator. Now, the reason it's all doubled up is that we typed it in and then it was echoed back, so it would show up on our screen. But following the login as administrator, here's our password, capital NUGGET !23. And my friends, we now have the administrator password for the domain. Also, because our sniffing is still going on, if we go back to hosts, it's also discovered a few other devices. So there's the actual host that's running my VMware workstation. .201 is another machine I have here that I'm recording from. 1.1 is my default gateway. And if we go back to passwords and we scroll down this list, I also noticed that we have SNMP as well. And for SNMP, that was like a freebie. So the SNMP server is the SNMP service that's running on my printer. The client is .210, which is my Windows 10 machine. And we installed some SolarWinds management tools in an earlier nugget. And as a result of that information being sent, also in clear text, Cain was able to collect that community string, aka the password that we're using for SNMP, and that would be another piece of information that we can use to further compromise or at least learn more about the network. In this nugget, we demonstrated a man-in-the-middle and sniffing attack to discover passwords that are being sent in plain text. I hope this has been informative for you, and I'd like to thank you for viewing.